Consider the graph of the polynomial. They give you a polynomial and they graph it for you. And notice that the graph is not drawn to scale. They ask you, the first question is to state the degree of the polynomial. Now remember, the degree of the polynomial is what is the largest exponent. In this case, the exponent is 3. And remember, this is to the third power, so it'll be 1, 2, 3. So this is degree of 3. Most of the time I will say this is a third degree polynomial. And the degree will also tell you what is the maximum number of times that I can cross the x-axis. In this case it will be 1, 2, and 3. Now letter B. Write the polynomial in factor form. Now to be able to write in factor form, we can first try to see if we can factor this out. We have 1, 2, 3, and 4 terms. So therefore we're going to be doing it by grouping. Whenever you have in 4 terms, we do it by grouping. We group the first 2 and the second 2. So what can I factor out of those 2? Nothing divides 5 and 7. But I can factor in x squared. And what's left behind? What do I need to multiply x squared to end up with 5x to the third will be 5x. And x squared multiplied by what is negative 7x squared will be negative 7. On the second one, what can I factor out? I can factor out a 4, negative 4. And what's left behind? Negative 4 times what gives you 28x will be 7x. And negative 4 multiplied by what gives you 12 will be negative 3. So we have a problem that those two are not the same. So this cannot be done by grouping. But they still ask me to do it by placing in factor form. But I notice that there's a root that's given to me. So I know that the root is x is equal to 3. So therefore, if this is a root, I can use my synthetic division. And I'm going to let x equal to 3. And since this is a root, my remainder should be 0. So let's try this out. Am I missing any exponents? We have a x to the third, x squared, and x, and then the number. So I'm not missing any exponent. So I'm just going to bring down my coefficients. We have a 5, and negative 7, and negative 28, and a positive 12. I'm going to place a 0 here. Then, remember that we always start with a 0. We add. Then we multiply. 3 times 5 is 15. We add. 3 times 8 is 24. We add. 3 times negative 4 is negative 12. We add. And just like we wanted to, since this is a root, our remainder should be 0. Now, that was to the third power, degree of 3. So therefore, this will come down to x squared to the degree of 2. Then we have an x and then the number. We don't need the 0. So let's go and rewrite it. So we have 5x squared plus 8x minus 4. Our other factor comes from here. That's a positive 3. So therefore, will be x minus 3. Because once we solve it, we have to place equal to 0 and becomes x equal to 3. And now we're going to factor this out because we need to place it in factor form. So I'll place my double parenthesis because we have 3 terms. 1, 2, 3. We're going to do it by double parenthesis. Factors of 5x squared will give us 5x and x. Factors of 4, I can use 4 and 1 or 2 and 2. And I need to end up with a positive 8. So therefore I use 2 and 2. That's a negative. So one of them should be negative, the other one should be positive. I'm going to make that a negative and that's a positive. Because that will give me a positive 10 minus 2 will give me the positive 8. And I'm still going to bring my x minus 3. This is fully factored. So therefore that is in factor form. and we have y is equal to. Now, letter C says, state the coordinates of the polynomial's root. So first we need to find the roots. Now, to find the roots, you're going to let y equal to 0. And we're going to use the zero product property because they're multiplying and they're equal to 0. We're going to place each one equal to 0. So we have 5x minus 2 equal to 0. X plus 2 equal to 0. X minus 3 equal to 0. And now we're going to solve it. I'm going to move my 2 to the right, becomes a positive 2. So we have 5x is equal to 2. I'm going to divide by 5 on both sides to leave the x by itself. So x is equal to 2 over 5. On the second one, I'm going to move my 2 to the right, becomes a negative 2. And on the last one, I'm going to move my 3 to the right, becomes a positive 3. You want to make sure that you are careful. They're asking you to be able to rewrite, to state the coordinates. So therefore, I need to place it as a point. This is the x value, 2 over 5. And the y is 0. This is the x value, negative 2. And the y is 0. This is the value 3, which was already given to us. And the y is 0. So that's where it crosses the x-axis. So therefore, this will be 3 is there. Negative 2 and 0 is right here. And 2/5 and 0 is right here. Those are the roots of the polynomial.